And we are live. Welcome everybody to the new webinar. This time I have a new guest with me, Robbert. Today we're going to talk about testing frameworks in DBT. So thanks all for joining. I hope the sound is okay. I hope the video is okay. Let me know in the comments if things are not working very well. Last time we did this, we were struggling with some sound, to be honest. So let's hope we do it better this time. So we prepared a few slides. Let me add that to the screen. There we go. Don't worry, we're going to switch to demo soon enough, right? Welcome to this webinar about DBT testing frameworks. The agenda of today is that first we're going to talk a bit about why we use frameworks in the first place. Why not just do DBT test? Because if you've been playing around with DBT for a while, you know that DBT has tests available, right? So why make it more complex than that? And which tests do we actually do, right? So there's going to be a few slides to just give you a broad overview of what kind of tests we do and where. Then we're going to do a demo. We're going to see live in an actual scenario where we're going to do the testing and how. So you can follow along with code instead of looking at slides. We're going to use our own tool to demo that conveyor. Conveyor we use to get anything we want to production. So here, Robbert will show how he uses conveyor and Airflow to get the testing frameworks live. Right. Finally, there's some time for Q&A. But before we dive in, we always do a Mentimeter. I think you're used to that by now, so I'm going to quickly jump to the Mentimeter thingy. All right. So if you go to menti.com and you enter this code, 29261374. It's going to be a few questions for you to answer. So yeah, I'll wait for a bit. There's usually some lag on the line. So go to menti.com, 29261374, and yeah, there's going to be some questions there. So the first question we always ask is, what do you want to get out of this webinar? What do you want to learn today? I hope we can cover everything. If you haven't entered the code yet, it's still here on top. So menti.com, 29261374. I'll wait a bit until the answers come in. New insights on testing DBT code and data quality. All right, cool. I hope we can do that. Yeah, maybe they're not new to you. I don't know. Learn how to implement testing. Insights on how to test and workflows. More info about test frameworks. Yeah, okay, yeah, that makes a lot of sense. By the way, a lot about testing is also just getting started, because we notice sometimes if you don't do it from the beginning, if you don't build it as a habit to write some tests, you're not very motivated to add them afterwards, right? So here, this was actually, we're bringing this content because we were doing a large project at Onderwijs Vlaanderen, and I checked with them I could share. And for them, data quality and having robust data pipelines was super important. So we were building a new kind of platform. And we sat down from the beginning to set out how we wanted to test the various workflows in the platform. Now, we're still in, let's say, early days of setting up that platform. So we'll have to see how much of this stands the test of time, like when we're actually doing large-scale workflows in production. But at least this is our approach that we have found today, right? So also your feedback, if you see like, oh, Kris, you might be missing this, or you're a bit naive there, or be careful for that, feel free to give your responses, all right. In the meantime, let's see, high-level overview, learn about testing frameworks. Reason why you wear ties? That's a good question. So we did it last time with ducks because we talked about DuckDB. Now we have a tie with bubbles on them. I don't know if you can see that really well on the screen, but it's a bunch of bubbles. So if you think you know why we're wearing bubble ties, yeah, write it in the comments. If not, if nobody guesses, we'll share it at the end. But I hope it's clear to at least some of you why we wear a bubble tie. High-level understanding on how you guys do automated testing. So you find some dirty data. So what? What do you do? Okay. More knowledge of test procedures. All right. I think we get a fair understanding of what you guys hope to get out of this. We're curious, before we show how we do it, I'm curious to know how you do it today, right? So how do you test your pipelines today? How do you test your pipelines today? It's an open-ended question, so you can just say, we don't do any testing, we do DBT test, we write Python tests. We use a certain framework that we love.
Also mention if you use any packages, you can do DBT tests. You can also use them.
Yeah, I'm gonna add you to the webinar. By the way, I forgot that. Boom. Yeah. Okay. Now your mic is on. Yeah. So if you use any packages as well inside of DBT test, indeed, let us know. Very basic, not a unique test. Yeah. Manually test at all. Check. So this is very recognizable. Again, we're not, we say, holier than thou. It's not that we do all of this perfect, but we fall in the same trap. We only do manual tests, only not unique tests. The problem with that is, the problem is exactly what's on the screen. We see if it fails in production. And that is, I think us engineers sometimes underestimate, let's say, the reputation damage you do with that. If your client, I mean your end user, not the client, but if the end user has talked to the data team and tell you there's something wrong with the data, there's something wrong in the dashboards, and it's been wrong for 2 weeks, you haven't noticed, then you lose a lot of credibility with the end client. I'm not saying it never happens, right? It also happens to us, but try to avoid it as much as possible. And this is actually a way of how to avoid breaking pipelines, breaking data in production, breaking dashboards. It's something, it doesn't add immediate feature value, if you will. It doesn't add immediate business value, but it really helps you keep, let's say, a good reputation to the rest of the organization. Okay, so the tests, great expectations, PyTest. Whoa, that's a lot of different frameworks you use there. That's nice. Mass testing, aka see if society collapses due to my push. Yeah, that's kind of fatalistic approach to testing. Yeah, sure. All right. One specific question more zoomed in is for those of you who are using DBT. I guess a lot of you use DBT, otherwise you wouldn't be here. Do you already use contracts? Because that's you're going to see Robbert talk about it. It's one of the things that we added. We consider it to be a kind of a test as well. So okay, you read some things about it, but never used it. Okay, curious to see if somebody is using it already. Yeah. Nyan, you're signaling something to us. I guess the sound is bad, but you should also add it to the comments so we can read it. Yeah, sorry guys, if the sound is bad again, it's something I don't know. I attract bad sound quality for some reason. All right. Okay, that makes sense. So most of you don't know anything about it. Some of you have read about it. One person has played with it. So let's see. 2 persons played with it. Okay. Remove. Okay, I'm going to add my screen. Remove my screen. Robbert, I'm going to give the floor to you. I'm going to add your webcam. And then feel free to share our approach.
Thank you. Is the sound okay? Yeah, you can maybe leave it in the comments. So first of all, I want to start out with some references because I got great inspiration from this talk from Mario Rogers at Coalesce. And yeah, those links in the slides will all be sent to you after the webinar, so you can come back to it if you still want to watch that talk or go to any of the other references. Now, of course, there is this blog post that's already out there on Medium that also covers some of the topics that we'll cover here. And then we're going to do a demo at the end, and that code is also public. You can find it at the link. So the key idea of Maria is why do you test? Like there's 2 fundamentally different tests. There is, on the one hand, there is assumptions about your data, so you're testing your data. On the other hand, you're testing code. But if you just do DBT tests and you don't make the distinction explicitly, what you're always like monitoring is the output data. That's where you're doing your checks. That's where you're evaluating your checks. And then, if you look at it from a systems perspective, like if you say DBT is my system, then your inputs are both your code and some input data, and your output is just some data that you're running your checks against. And so if one of those checks at the output data goes wrong, then how do you know what caused the issue? Was it your code or was it your data? And so Maria's proposal is to like explicitly make the distinction between those two, and she says, with data we make assumptions, for code we make assertions. And so if you want to test your code, so again, systems perspective, you freeze all other inputs except for your code. You can change your code. And then you monitor how your output changes. So when developing, you want to freeze all other inputs, and in our case, you want to freeze your data. That will mean mocking, using mock data, because that like stays fixed. And then you develop your code that changes all the time. You monitor your output and see if that matches your expectations, or your assertions, if you want. Then for your data, you want to do the inverse. You want to freeze everything except for your input data. That's like naturally, if you push code, it's frozen in production, at least for that commit. Maybe your pipelines run daily, so there's always new data flowing in. And again, you monitor the output, which is your data. You monitor your assumptions. And if you go back one slide, you can see on the top right, there is like, usually this is, you do this in local development or also in your CI. And then the data assumptions, you test them in production, usually. So, okay, if you want to take this approach, like make this explicit distinction, like how do you do it with DBT? And then what we found that, when researching it at Onder West-Vlaanderen, we found 4 different kinds of tests for 4 different cases. We started out with like, how do we test these models, these DBT models? Because those are code, and you're developing code, and you want to be able to run these tests irrespective of your production data. And so we tried to find a framework that would like help us do that. And then we came across DBT unit testing. It's a package, a DBT package. I'll go into depth more later. But then, there are some limitations with that when you want to test macro code, which is also code. But DBT unit testing is not the best way to approach testing macros. So then, we found a way that works with just regular DBT tests. And then in production, you want to do the data assumption testing. And then there we found Soda for testing the content of the data assumptions. And since I think a month or so ago, DBT 1.5 is released, and that brings us DBT data contracts. And I'm very fond of it. I really like it. We'll zoom into that later. So first of all, testing the model code with this DBT unit testing framework. One slightly scary thing is that you have to replace your refs and sources in all of your models with the DBT unit testing version. But if you look at the source code for what's behind this DBT unit testing ref and source, it's really only 10 lines of code, and it just makes the switch between like, are you running your model like in production, or are you running it to do testing? And that's all it does. And if you read that code for the DBT unit testing ref and source, then that brought me a lot of comfort, because I thought it was a bit scary, but in the end, it's fine. And if you do that, then the beauty is of this framework, it can inject mock data as defined below, as if you were running it against real data. But then how do you define this mock data? It's also in test file that you have in your test folders in your DBT project with a bunch of macros. And these macros, I think they put a lot of work in it, because you can even choose the input format. You can put it to CSV, and then even specify separators and types all in the CSV. Or you can just do regular SQL and do select, I don't know, one as ID and 150 as some number and so on.
Maybe if I can add something to it, I hope my sound is better now, by the way, because I put my earbuds in. I don't know, leave something in the comments if the sound is better, or if you're still hearing echo, then I'll mute myself again. But what I want to add to this is the kind of testing that I see least in data. So in all software engineering, everybody writes unit tests all the time. Like, just to test your logic with some fake data going in, you test your logic and you run those unit tests all the time. When we see tests in the data world, it's more 99% of the time what people said, I'm testing if a field is unique, if it's not nulls, like data test. But that doesn't say anything about the code you've just written, right? And a pipeline can crash because the code you updated fails, and you made a mistake there, or the pipeline can crash because you get faulty data in. But this kind of actual code-focused tests we don't see a lot. We hear you from far. Okay, through the mic of Robbert. Yeah, this is going to be good enough. It's going to be like this, guys. I'm sorry for that. Anyway, so this kind of code testing, I think, is the most important kind of testing, because it really tests, well, your own logic. And if you work with a team and you add a lot of changes, you want to make sure that when you keep doing changes across a team, that you don't break somebody else's code, or they don't break your code, or you don't break your own code. So if I would do one kind of testing, it's actually this. All right.
Yeah, and I would also argue, like, test your most complex models. Like, don't bother writing tests if they're not going to produce value. If it's a simple select star from some source table, I don't think you should bother write tests. Like, keep it simple and only write tests if you're for the logic.
No, that is very true. It's the same in software engineering. If your code doesn't do anything, just select star from a table. You don't have to test if your database can do select star. It can do a select star, right? It is about testing logic, testing your own logic, right?
Yeah. So yeah, I marked some interesting keywords in the code in green. I think one that we didn't cover is this expect. So you can also, next to your mock data, mock sources, mock refs, you can also, you have to also specify which data you expect. So those mocks will all be fed into your model, and then the expectation is what you get out of it. But then, we wanted to test macros as well, and that usually is somewhat more complicated logic. So you really want to test that. But then this DBT unit testing framework is really designed for DBT models, not for macros. And then I experimented with, like, could we make models specifically to test macros, but it gets so complicated, and you don't want to run these models then in production, and you do want them during testing. So I took a step back and just wrote something that I think works well just with plain DBT tests, where the format is kind of the same. Like, you also put in some input data, and you define what kind of expected output you have. So in this case, it's a formatting function that removes some dashes, and it's a white space formatting function. And then you do the actual calculation here in this macro output, where you call the macro on your input data, and then you for each of these rows you also have your expected output defined, so you can check whether it matches. And the nice thing is that with DBT tests, test fails when it returns rows. So the only thing you have to do is, like, wherever this is different, the macro output is different from the expected output, that's your test, that's your select statement. So yeah, fits quite well, I think. And the nice thing about the way this is written is that your input and expected output are close together. So you can really see, like, okay, these underscores are disappearing and the dashes are gone. And then when we want to test data, the framework we chose is Soda. And there's a bunch of these data observability frameworks. There's actually even a topic on GitHub. You can search for hashtag data-observability on GitHub, and you'll come across a few frameworks. And I think all of them integrate or work with the DBT. But Soda is loose from DBT. It just needs connection to your data warehouse. As you can see on the left, you have to specify your connection basically, and then on the right, that's what these checks look like. And what we really liked about this is that it has its own language. Right? It's all YAML files, but it's super simple. You can almost read it almost as if it's English. And it checks for customers. Duplicate count of customer ID is 0. I mean, I don't know if there's actually a business person that would write YAML, but it's getting close.
Yeah, it's close enough to sit together with a functional analyst or a business person. I mean, more technical business person to say, is this what you expect from your data? Does this describe your data well? And he can go over it, and indeed, it's just plain English. You just read it and go check. And compared to others, I think we also looked at great expectations, right?
Yeah.
And there was more cumbersome.
Yeah, those the other data observability frameworks, they all integrate with DBT. They have DBT packages, but I thought it was pretty nice to actually have these separate, because like the audience is also probably separate for these checks. Yeah. And then the last one, my favorite, DBT contracts. It's actually a way to enforce schema. So you can really, there's literally a config that says enforced. And so you could already specify data types for your columns, I believe. But now you can also enforce them. And the nice thing is your model will not run if it breaks the contract. So it doesn't even start. And that's really nice because you will not break anything downstream. It will error out. You will have to fix the error. Possibly you go back to some upstream table that changed to the team that's responsible for that. Ask them what changed. Do you really need this change? I don't know. Communicate with them and resolve the issue before breaking anything downstream. Yeah. So that's kind of the overview, the 4 different tests that we have and test frameworks for them. Now we're gonna have a small demo, and I have 2 slides on the tech stack. Can anyone guess a big part of our tech stack? I used some Dream Studio, Stable Diffusion.
In the meantime, while guessing, there's a question: what is the reason you choose to do contracts on the transform step and not in the extract step?
Yeah. So I think this depends on your organization. If you're in a very mature organization and you all apply these contracts on your output on the very end, on your marts, if you will, then you can look at it as an API, like in software. And if everybody like adheres to their API, then I don't expect many problems. But indeed, you can also apply these contracts to the very beginning of your in your staging models to check whether someone else broke their API. And we also do that in the demo, I believe. The staging models also have contracts defined. The only place I would not do them is like in intermediate models. That doesn't really make sense to me to define contracts for your intermediate calculations that are not exposed to anyone else.
No, because indeed, well, the contracts are, as they say, they are to enforce a certain interface. And I think that flows can be both. It can be to check whether whoever you're consuming from, that they respect their contract, that they don't break anything. But yeah, the best way, I think, or the first way to do it is to indeed on your own out. It might be that your pipeline fails because you broke your contract. But then at least, like your downstream users, they only get stable data, but they don't get their own data, right? So you can be assured that you respect your contract. I think half of the reason why pipelines break is because people change something in their tables. That's like half of the reason. So if you can just block that would be nice. Yeah, audio is broken. I'll mute myself again. Sorry. Okay, but then you hear me a bit from the back. So nobody could guess. Well, no, somebody could guess this text stack. So indeed, Airflow is the right, but the left one is not Hadoop. And that was also my guess, by the way. It was Hadoop, but actually, Robbert, it's up to you to explain why what the picture is.
Yeah, it's a different elephant. It's still an elephant. It's cruising on a whale. So it's actually Postgres on Docker. So Dockerized Postgres. And then in production, we use Airflow. So for the demo that I'm about to show you, we'll see this local development setup with this Dockerized Postgres. Yeah, I'll show you around in the 4 different kinds of tests in our DBT repo. And then when we push changes to Git, there's actually a CI going to run, and it's going to run these macro tests and the unit tests to verify that the code that you're pushing is actually correct. And then in prod, you will see that we do these SODA checks, and then we also do the data contracts there, but it doesn't really show in Airflow because it's really built into DBT. You'll only see that these DBT models have run, hopefully, and that means that the contracts are like didn't fail. All right, demo time. So I have my repository here. I hope it's big enough for the viewers. My repository here, the DBT repository, you can already see like one folder is different, this SODA folder, but we'll get into that later. Let's start with this DBT unit test. So in my test folder, I divide it in between macros and unit tests. And for these unit tests, if you go to models, I am testing my MART because those contain actual complicated logic. It's 40 lines, it's still okay. But it contains some logic, and we want to test that. So this is what the test looks like. You have some refs that you want to mock, and if you go through this to this file, the original model, then you have to cover every ref, and you see it's also using the DBT unit testing.ref. Every ref and every source that you use in this model has to be mocked in order for this unit testing test to run. So you give a small description. You mock both the refs that are used in the customer's model. In this case, our customer is Francis de Grote, and he's purchasing some coffee. And then if you run this right here, use select. Let's see.
While this runs, Wim asks, is there any specific reason you use CSV over SQL mocking?
Actually, no. I personally prefer SQL, actually. But Kris really is fond of this CSV layout.
Yeah, it's personal preference one. So indeed, I like CSV better because it looks like an Excel file almost. But if you like SQL mocking, you can do it as well. Yeah.
But I think one advantage of having this CSV is that it's actually valid CSV, so you could extract it from some file if you run this customers model. Let's see, you could export this to CSV, grab a few lines, and then you have some input data. Well, be careful with that because, of course, you don't want to have sensitive data in your tests. But at least like for the columns or the format, it is valid CSV. So this isn't that interesting at all. It's a successful test, but like if I change one of these expected outputs, in this case, that's typically something you wouldn't change. You would change your logic and then see if it returns something different. But the cool thing is also about this framework, the output, it gives you the diff. It highlights this column like, okay, in lifetime spend, we expect 211, but instead what your model returns is 212. So you can really pinpoint this is going wrong. That's, I think, is quite cool. And then for our macro tests, it uses these standard DBT tests. We can run it using selector again, macros, and again, cool story. When I was building this demo, I actually caught a bug in the code because, like it says here, this was the first line of test that I wrote, the basic case, and even the basic case was wrong. Why? Because the macro that I inherited didn't include this .0 at the end. So it's cents to dollars. It's just a division by 100 because like all the data is in cents, but in the end you want to display something in US dollars because nobody like uses cents. And so it had this /100, and so I ran this test, and it said like it failed, and I was like, huh, why? And the cool thing is with this standard DBT tests, as I mentioned, the failing lines, if there are any lines that return in a test, then it's failing. And so you could also evaluate this, and then this is the evaluation of that test. There are more than 0 lines, so the test fails. But the cool thing is you can still run this and see what failed lines are there. And then I saw the output call is 4, while expected is 4.2. And then I knew, okay, this is this integer division. Well, we need float division. And then I put the .0 and everything worked. So yeah, even for very dumb, this is a one-liner macro, very dumb logic, even then it makes sense to write these tests. And then it's also good always to leave some comments behind for the rest of your team. To mention what you're actually testing. So the basic case in my case was most valuable, and then it also makes sense to think about edge cases and also list those. Like, what if my input is 0? What if it's very big? What if it's not a floating point but an exact integer? Yeah, some edge cases, and it also makes sense, to document it a little bit, like what you're trying to test. So that's for code. And then, I can also show you, since we're with the code testing, the GitHub repo. It has this check mark, this nice green check mark. And here it also runs these tests. So you can't see the selector, but I actually use the selector twice. So once for testing macros and once for testing the models. and then you can see the output in CI. And when you're developing a new model, you write tests for it, you push it to Git, automatically the CI will run, and it will tell you, sorry, but I'm not gonna let you merge this into main because your CI is failing. So actually very good to catch regression bugs. If you have a test suite already and someone changes a model, then the CI can tell you like, okay, there's no way this is going to master because the CI is failing.
And once this is automated for every commit you do, a whole suite of tests run, it should give you a lot more confidence about what you're doing versus I do some manual tests here and there.
Yeah, indeed.
So that should speed up your development, right? In the end, doing automated testing should speed up the development of your data projects.
Yeah. And then for these data tests, so as I mentioned, we use Soda for that, and checks look a little bit like this, where in this case I've only tested my marts, orders and customers, and because that's really where you make assumptions. You typically don't make assumptions about intermediate models, maybe about staging you can, but it's like really things that make business sense. I think the best example I have is like the average of an order. It's a coffee shop. It should be between $1 and $100 US. And the comment is, we sell coffee, not yachts. If anyone goes, buys more than 100, then there's something suspicious with our data. And again, if it's not clear from the checks language, it also makes sense here to leave some documentation about these tests. Like, what are you trying to check? If you have more than 10,000 customers, you probably need to open up a new store. You can do things like basically enumerations. What are allowed values? If there's some other type in besides new and returning, then there's something wrong. This one I really like. So you could have like the company agreement to tag all sensitive columns to like name all sensitive comments to start with PII underscore. And also check for that, like if there's any PII in your marts, in the data that you expose to others, you can also check for that. I think that's cool. Yeah, you can also after the webinar go and check out the repo and read some of these tests. You can also go to the Soda docs to see what's possible. But this is what this checks language looks like. I'm quite fond of it. We run it. In this case, I made this run soda.sh script, but it's actually just 2 lines, 2 lines that matter. Where I like to check the connection, because if someone else is running this and they don't have the right environment variable sourced or whatever, then the test connection will already fail. So I like to include that before doing the actual Soda scan. But usually you run these just to test whether your tests are valid. But like in development, only some of these make sense. I mean, this row count, you might have in your local development setup not have the real data set. You probably don't. So some of these checks just don't make sense in development. And then there's one more type of tests, which is the contracts. These contracts, you actually, like the bigger part of your time you spend in these models.yaml, defining the schema that you expect. And it's really quite strict. it checks whether your whether columns are all present in your contract, if that matches, and the data types. So if I just dbt run, yeah, I should have. Okay, I'm in the wrong folder as well. Then again, pretty boring. Everything's successfully, but if I expect another type somewhere, yeah, usually this is not the way it goes. The way it goes is someone, yeah, you have these tests deployed in production, and someone else changes your data. Like it's easier to show you like this. If you dbt run, then the nice thing is it fails. It doesn't start building the model. There's no impact on your data warehouse. Nothing changes. It says, I won't run because this customer ID is a text while the contract states that it's a float. If I would run the model, it would produce text, and that's not okay. The contract states is not okay. And then in production, that looks a little bit like this. So this is our conveyor environment. In this case, we mainly use the Airflow component of it. I have this code like running in production, scheduled daily. So if we can trigger a run here, and then we can look at the output. So this one is running. I can take the one of yesterday. And as you can see, my DAG is running staging, running marts, and then these soda tests. And staging and marts includes these contracts. So they will also turn red if any contract is broken.
And so here it doesn't make sense to run your dbt test or dbt unit test, because those things check your code, and your code should have been validated before it gets to production, right? You can't validate data before it gets to production because that's the point, right? But you can check your code. So here in production, we actually check if the data is correct, while the whole code correctness thing we do either on the local laptop or in CI/CD, or maybe in a dev environment where not in production, right?
Yeah, indeed. And so yeah, I can go have a look at the logs, and in this case, yeah, it says all of my checks have passed. I don't know if something goes wrong in some duplication script that run, and I have double the data, so then we might see that this row count fails, or I don't know. These are really business assumptions about the data.
Exactly.
I think that's it for my demo.
All right. There's a question from Floris. I'll shout a bit. I know you can't hear me well. But let's say you identify some non-conforming data and you find it using tests. Imagine you don't want the pipeline to fail, but instead yield a response to the owner. Is there a clear way to set this up? Like filter out the impacted rows, run the models, and report on the delta. Imagine a scenario where one row is wrong and your pipeline fails, but you want to continue. Would you do an explicit filtering step in the model instead? So I think what he asks, if instead of failing, can you also give warnings, right?
For soda, that's a thing. I think one of these checks says invalid % customer name smaller than 10%. Yeah, in this case, it was, if you go look at the soda checks, what is a valid name? It's quite strictly defined. It could only contain these 26 characters, upper or lowercase. Yeah, some names have accents, or so the rule is quite strictly defined here. So we don't put it to exactly 0. We say, okay, it's all right if less than 10% fails this test.
Exactly. So that's part of the answer. I think, Floris, you can set it so that one failing line doesn't break your entire pipeline. Or, well, actually, Soda also doesn't. you don't have to stop your pipeline. Even if your soda test fails, you can still decide in your Airflow deck to continue building whatever you're building, right? You can choose to continue run, or you can say, no, if the soda test fails, you stop the pipeline. But even then, you can still say, okay, soda only fail when there is a certain percentage of failures or a certain number of failures. So you can choose that. Filtering out rows and funneling them through, well, other tables and stuff. I think you have to do a bit more manual there, right? I'm not sure if you can, Soda can highlight exactly when here, these are the rows that are failing.
Not with the core version.
Yeah, okay.
But yeah, this filtering, that's actual logic. And then, yeah, that has to be incorporated into your model. Someone has to write it.
Okay, yeah, all right. With that, we are nearing the end of the webinar. I hope this makes sense. I have still a few more questions for you guys on Mentimeter. If you have questions for us, either post them on Mentimeter or in the comments. So I'm going to add Robert's, add my own screen again. So if there are any questions, I think here on Mentimeter you can ask also in the comments. Feel free to ask some more questions. Yeah. I also, what we do every time is we ask to rate the session. So did you learn something today? Was it easy to follow? Did it fulfill your expectations? Is there a good mix between theory and examples? And do you want to try it out yourself, right? So this is good feedback for us to have. While you're completing this one, I also have I think a quick announcement that we're also going to do a hackathon around this. We're going to help you get started. As I said in the beginning of the webinar, the most important thing about testing is getting started, right? Your first test, start doing it from the beginning, and then all that automation and all, once it's set up, it will come in handy. If you do it late after you've been writing DBT models for a year, it's going to suck, right? To add them later. So if you do it from the beginning, it's a win. We're going to make it very hands-on. So bring your laptop. You're supposed to write code yourself. The 3rd of August, 7 p.m. I'll see if there's some more questions. There's some questions here. Pointed to the demo code. I think it's open source, right? We'll share a link afterwards to the. And we'll also put it in the comments of the video where you can find the demo code. Let's see if there's some other. Yeah, there's an echo. Yeah, again, maybe I'm tempting to throw out all the hardware we have and start from scratch with audio and video because clearly this is not working. But I'll try to do better next time. Apologies for that. See if there's some other comments here. No, I think we covered everything. All right. The good thing is that not only the audio broke, also our screen is frozen, so that complements each other really well. But I hope you enjoyed the webinar. I think the most important thing was Robbert sharing what he did. Thanks again, Robbert, for adding the super structured and valuable information. I hope you guys can do something with it. And I see you in the next webinar. All right, guys. Bye.
Bye.